I'm recording. Okay, let's just look at them. So when we want to multiply fractions, let's do something like we did yesterday. So 2/3 multiplied by 1/4. Put your hand up if from yesterday, you're pretty sure you know how to do that. Yeah? That's not what I'm asking. I'm just asking, do we know how to do the answer at the moment? Yeah? Go on and Justin, tell me the answer. Okay, so we do 2 times 1 as the numerator and we get 2. 3 times 4 as the denominator and we get, well, I don't remember asking for this, but thank you for shouting out. You are correct. But thank you, Justin, that's what I asked for, yeah? So from yesterday's assessment, did you all figure that out?
Yeah.
Take the 2 numerators and multiply them, take the 2 denominators. Okay? Yeah? Okay. So that's doing it, but we can simplify the result, and thanks to our shouty outer, we've been told it is 1/6. Because, okay, Caelan, can you explain why doing that does simplify the fraction?
Because
It's a bit vague. Any better understanding? But I could make it both smaller, but it wouldn't be an equivalent fraction. Okay. So one thing, just so we can add something here. Why does this simplify? So I'm going to do it. Thank you very much, but I'm going to do it. Okay? I'm going to do an explanation of simplify. And we're kind of going to use the multiplying thing. So if I want to simplify 2/12, what I'm actually going to do, you might not be telling me what I want to say. So I'm just going to say, maybe it is you tell me. Right? I'm going to actually convert this back into a multiplication. And I'm going to say it's the same thing as 2 times 1 divided by 2 times 6. Okay? Now, do you notice how this bit kind of looks like that bit now, yeah? Alright? So I'm going backwards. So are you happy if I've written that I can then separate it? So I can write it as 2 halves times 1/6. Does that make sense? Yeah? So we've kind of gone backwards. So 2/3 times 1/4 is the same thing as doing 2 halves times 1/6. Is that all right? It's quite a high level thing I'm doing here now, so I'm hoping I'm keeping you all with me. Right? If you're zoning out at this stage, like you're going to miss this. So this explains why 2/12 and 1/6 are the same, because what is 2 halves the same as? It's the same as 1, isn't it? 1 times 1/6. 2 halves is a whole 1. And what happens if you multiply anything by 1? It's the same thing. So I can do, so when Caelan's quite right, he said we can divide by 2 and 2 is a common factor, but what I've just shown you is why that works. Why are we allowed to do it? Yeah? Make sense? That's simplifying after. So we've done two things there. We've shown how to multiply and we've shown how to simplify. Now, just as a note here, you don't have to go through this process every time. All right? It helps if you understand why things are happening. That's all. You don't have. We can just do what we did here: divide by 2, divide by 2. But it shows you why it has to be the same number on the top and the bottom, right? Because otherwise you wouldn't get the 1 times. Questions, Owen?
If we do a criterion D test, on the have to justify, could we use this?
Well, actually, because this is explaining how a pattern you've seen explains something that works. Yeah, it's like you've just done. The criterion D is more like applying this situation and explaining why your answer makes sense, but in a real world context. What's your question?
The numerator of 2, but also couldn't it be the highest common factor that they could both be?
Yes, well, that as well. Yeah, definitely. You're right. When I split it here, I took the highest common factor, which is 2. Should we add that to our notes? Highest common factor, yeah, of 2 and 12. So you can see how when we did that earlier on in the term, in the year, now that's becoming useful. Write this down, Daisy?
Yeah.
Yeah. Okay. Another question then. Let's do 2/7 times 3/8. So can you do that and simplify afterwards for me, please?
Simplify after.
Okay, got 3 questions. How we go? Okay, ladies and gentlemen, I'm back to recording. I'm just going to talk you through this in a bit. I'm going to just do it the simple way. So we've got, the first one is 2 times 3 divided by 7 times 8 gives me 6 divided by 56. Okay? Now, to simplify it, I spot that that is, I can do 2 times 3 and 2 times 28. So if the 2 and the 2 make it, that's the 1 bit. So I'm left with 3 28s. Now, I can only simplify now if there's another factor. Now, 3 is a what kind of number? What's it called? It's a prime number. So prime numbers can only be divided by themselves. So unless 28 can be divided by 3, which it can't, I know I'm as simple as it can go. So that's my answer. And we're not there yet. I hope you understand that not everyone may be up to the same. No, I need to get everyone there. You've gone through this process, yeah? So let everyone get through this process. If you want to open the textbook, there's obviously questions to be done. If you want to get on with it. Not in the unit review, but you've done all that, haven't you? Previously, earlier on in the chapter. Next one then, which would be 4 times 2 divided by 6 times 3, which is 8 divided by 18. So that would be, okay, so we've got 2 times 4 over 2 times 9, which leaves me with 4 ninths. Okay. Now, one thing, by the way, for those that are good at this, if you just ignore this bit that I'm saying, if you ignore the fact that the 2 and the 2 don't just miraculously disappear, some people think they become nothing. Nothing is 0. 0 times anything is 0. So they don't disappear, they become 1, not 0. Now, as you get into algebraic fractions, in a couple of years' time, if you are in your head and things just disappear, become 0, mistakes happen from that understanding, misconception. So even if you're good at this, because you remember, oh, I just have to cross these out, remembering that those numbers make 1, like I said up here, is actually super. One bit you don't often make enough attention to. And then finally, the ones I give you.
Which it would be 5 times 12 over 3 times divided by 3 times 15, and that would give you 60 over 45. And then I divided that by 15.
15 times 4 and 15 times 3.
And then before.
So the answer would be 4 over 3. Good.
Wait, don't go any.
4/3 or 1 1/3. Which one's correct?
Yeah.
Both. Good. Right. Unless you are asked for both true. Just because it's got the word improper doesn't mean wrong.
Let's just put reasoning like words like this is they're both true because they're both.
It wouldn't be a trick question if I would said to you, give your answer as a mixed number or give your answer as an improper fraction. I would want one or the other. If I just said multiply those two fractions and you got this answer, it's correct. Yeah? If you went this step further, it's also correct, but I'm not going to give you any more marks. Unless in a test I'm saying, and write your answer as a mixed number. You don't have to worry about it. But it's good to be able to do, because in the future, again, these skills with fractions become really important in algebra. All right, what I'm going to do now, some of you might have figured out, we're going to simplify before doing the calculation. And the way I've been doing it, hopefully you'll understand why I'm doing it the way I'm doing it. So, I'm going to look at this one again. 5/3 times 12 15ths. I'm going to do it again. If you want to explain, I need a complete explanation with reasoning so everyone understands. You go for it?
So at the start, I saw that 5 and 15 were in the same times tables, so I crossed out the 5 and I put a 1 there, and I put and that.
I want to know why. Why am I allowed to not even that's not a good reason. That's a remembering a trick. It's not really a trick, it's a process, but you're not explaining why we're allowed to. Can you explain why we're allowed to? This is kind of why I'm not letting you jump in. I want everyone to understand. Do you know why? Why we're allowed to do it? What he's saying, guys, is you can cross that and put a 1 and cross that and put a 3. I mean, that's fine. And then this will cross, see? Yeah? Cross this, and that will be a. What? Yeah. But it's important that we actually. You see, this is what I'm trying to avoid. There you go. No, I mean, he is perfectly correct. And you'll all be doing this in a bit. Yeah, no, you will. Listen up then, guys. So what happens is this. This is the why am I allowed round. This is the why am I allowed. So basically, when we multiply, we can do 5. We're doing exactly what we did before, writing it like this. Okay? And we would do the answer and simplify the answer, yeah? Figure out what is the common factor, yeah? But actually, what is the law? What's one of the properties of multiplication that we can use to make things easier to do multiplication? What do we know about multiplication? Okay, yeah, that doesn't help me in this case, but you are correct with your statement. Is there anything else we know about multiplying two numbers together?
That they go together.
No? Anyone? It's the most basic one for multiplication.
Find this the same number.
Nothing to do with fractions, just multiplication.
Same number add same number.
It's what Justin said.
Maybe when you multiply and you get an answer, if you just like flip it around and
Okay, but that's included in it. Yeah, you've given me a correct statement. It's not 1 1. It's a really simple one. You'll probably go, oh right.
multiply numbers.
What I'm asking, there's a property of multiplication that I can use here.
Multiply both numbers.
That's not a property, that's a. No, not got it. Multiplication can be done in either order, right? I can do 5 times 12, but I can also do 12 times 5. We can do that because sometimes it makes it easier. What other operation is the same? No. Addition. I can add any way I like. Division I can't, to do it one way. Subtraction you can't. Got it? So that property, Daisy, that property of multiplication I'm now going to use. Now, this is what Amaro is using. He linked the 5 with the 15. And the reason why you're allowed to do that is because I'm going to write 5 times 12 as 12 times 5 instead. And I'm going to write 3 times 15. I'm going to keep that one the same. And then I'm going to do what I did before, which is split it back up, which is 12 thirds times 5 fifteenths. It's the same question. Got it? Okay. Now, could I simplify those fractions before doing any multiplication? So, what will 12 and 3 both divide by? 3. So I can do 4 times 3 and 1 times 3. So the 3 and the 3 leave me with just 4 over 1. Yeah? And we multiply by what do 5 and 15 share? 1/3, yeah? So 5 and 15, if I do 5 times 1 divided by 5 times 3, I'm left with the 1/3. You okay with that? Yeah. Ish.
So I write it down. I understand.
So now the answer is going to be 4 times 1 over 1 times 3, which equals 4 over 3, yeah. So I got the same answer.
Right after.
Lots of people say that, but if you give up, this is easier. Why do I think it's easier? Because the numbers are smaller, the times tables. Yeah? Or should we have a... Sorry, being polite. He was just getting on and sitting down. It's good. You didn't need to distract. Now, can I just ask you then, do you understand what Amaro is now saying? 5 and 15, if I divide them both by 5, I get the 1 and the 3. And the 3 and the 12 here becomes, divide by 3 is 1, becomes the 4. So I get the 1 and 1, and the 4 and the 3, the 1 and the 1, the 4 and the 3. The answer is, so that's just a quick way of writing it. All right?
Wait.
Should we have a go at another one? Let's have a go at that. Okay. Shall I give it to you to do, and then we'll see how you. Okay. Give me a question that can be done. Four fifths times.
No.
I'm going to go with 15 sixteenths. Have a go. This one, obviously, if you're going to get your calculators out because you don't know what 5 times 16 is, that's why we should simplify first. The idea is that we're now learning to do these with smaller numbers, so we don't need a calculator. Okay, Giovanni. Okay, so the 4 and the 5 don't simplify, the 15 and 16 don't simplify, but we do notice that the 4 and the 16. So we can write this as 4 divided by 16 times 15 divided by 5. You're not allowed to move them up or down, but we can move them across. Go on in, Giovanni. So 4 sixteenths simplifies by, divide by, well, it does by 2 as well, but let's go all the way to 4, the highest common factor. So 4 divided by 4 is 1. 16 divided by 4 is 4. Good. Times 15 and 5 both divide by 5. So I get 15 divided by 5 is 3. 5 divided by 5 is, now your answer is 1 times 3, 4 times 1, which is,
Dang it! I was what?
just to show you, if you wish, like this is good layout and good explanation, but as you get quicker at it and get good at it, you'll just start writing things up. 4 cancels with the 16, so divide by 4 makes 1, divide by 4 makes 4, that's the 1 and the 4. 5 and 15, 5 divided by 5 is 1, that's 3, and we end up with the answer. 1 over. As you get better at it. Justin. It's almost time. Okay?
You have 15 minutes.
Are you super desperate?
Nearly 5 minutes left.
Anyway, go, coming from you, Daisy. Go for it. Right, ladies and gentlemen, page 175, question 3. Okay?
Well, we have to.
Start that now. You've got 5 minutes, and then I'll decide whether I want to do homework for this minute.
We have been there.
All that means is I can give you a week's worth of homework to hand in when you get back.
We're tired.
Yeah.